TEK 12A is in the polynomial category, but we teach it in a linear unit. It is about functions versus relations, and the TEK says, the student is expected to decide whether relations represented verbally, tabularly, graphically, and symbolically define a function. I'm going to go through what each of those examples might look like, but to understand the difference between a function and a relation, we have to understand what the function machine really does. So a relation is any set of ordered pairs. Any data we have correlated together is considered a relation. But specifically, a function is a type of relation that has a one-to-one relationship. Okay? One-to-one relationship, which means that every x has at most one y. In other words, you cannot repeat the x's. If the x or the input that you put into the function machine has any output other than the same thing, then it is not a function. So if I put a 4 into my machine, I have to get a 7 out every time. I put another 4 in here and I get an 18 out of here. Those aren't the same outputs, and that would be considered a relation and not a function, because there's not a one-to-one relationship between my x's and y's. So what that might look like in a problem, if you're given verbally information and asked if it's a relation or a function, it's going to look like this. Let's say you're given the set of data represented by the coordinate points 0, 1, 0, 2, 0, or 1, 5, and 1, -3. Now this is not a function because if you notice, the x value of 0 repeated twice with a different output. Also, the input of 1, or the x value of 1, repeated twice and they didn't have the same output. That is not a one-to-one relationship. On the other hand, an example of a function represented verbally is the set of data represented by the coordinate points 0, 8, -9, 2, 1, 3, and -4, 3. Notice none of these x values, the first number in a coordinate pair, were the inputs repeated. This is considered a function. This is considered not a function. Tabularly, it's pretty much the same. We're going to be given a table. This is the same data from the verbal example, but just represented in a table. If you notice, it's almost easier to see that the x's are going to repeat in this relation, not a function. In a function, all of the x values are unique or new. They don't repeat. That's a tabular example of a relation versus a function. We might also have a graphic example. The graphically is going to be giving you the same information, coordinate points, on a graph. Maybe it's a connected line or a line segment, but nonetheless, it's information represented on a graph. These are the same points. Do you notice how the x values, which are along the x-axis, the inputs, repeat? They're stacked up vertically. That's going to be not a function. If they stack up vertically, that creates a relation. It's not a one-to-one scenario. A function, however, will not repeat any of the inputs. There's no vertical stacking of my points. There's no, it would pass what we call the vertical line test. Okay. Lastly, we're going to have a symbolic representation of functions and relations, and this is called a mapping. Okay, mapping is two circles that represent inputs and outputs and their connection between them. So this first example, same coordinates we've been using the whole time, says that 0 is partnered with 1, but also 0 is partnered with 2. There are 2 arrows that come out of an input over to an output. That's not a function. That's going to be just a relation. See how 1 is connected to both -3 and 5? Those are 2 coordinate points that start with an input of 1, therefore making it a relation and not a function. On the function side, however, we're going to be able to have a bunch of different unique inputs that go to different outputs. Now, some of you might notice, look, the 3 is repeated. It has -4, 3 and 1, 3. That's okay. I don't care if the outputs are repeated. I only care if the inputs or the x's are repeated. That's what makes it not a function. If these all have unique or one lines coming out of them to head to any output, then it's a function. Here's an example question that you might see on a STAR or on a teacher test. It says, which table does not show y as a function of x? You're looking for here is as a function of. We're really asking in a fancy mathematical way, which one is not a function? Okay, so we know that functions need to have unique x's. So if we identify one of these tables that has a repeating x value, that's going to be our answer because that is not a function. So let's look here. We have a unique 1/10, 1/8, 1/5, 1/4, 1/2. Did any of those repeat? No. So this is considered a function, so we don't want to answer that because we're looking for one that's not a function. How about 14, 15, 16, 17, and 18? Did any of those repeat? No. That's also a function. We've got negative 0.2, 0.6, negative 1.3, 1.0, and negative 0.2. Hopefully you noticed here that this negative 0.2 is a repeated input value with different output values here underneath it. That makes this a relation and not a function, which is exactly what we're looking for. We'll hang on to that one. We check the last answer choice because that's good test taking habits. We've got negative 24, 21, 24, negative 27, and 29. Those are all unique numbers, so this is also a function because there's a one-to-one relationship. We would therefore choose answer choice H as the example that is not a function, that does not show y as a function of x. As always, we empower, we impact, we love, we are Skeeter Nation.